Okay, good afternoon Nana, good afternoon everyone. So after completion of this unit 3, okay, after completion of this unit 3 in modern physics, I would like to continue the two papers, okay. In the morning 9:45 basic electronics, okay, that is basic electronics paper, and next in the afternoon session I will take this modern physics class. So up to that I am continue this modern physics both 2 hours, okay. So please listen every day 2 classes, that is only modern physics, okay. I would like to complete first unit 3. After completion of unit 3 only I would like to continue the 2 papers, okay. Up to that you have to listen carefully. So as of now we have discussed about some basic theory regarding the nuclear physics, okay. Now I would like to deal with the size. What is the size and what is the radius and what is the mass? Some of the basic properties of the nucleus, okay. So some of the basic properties of the nucleus means, so what is nucleus? First of all, already I told you, a positively charged sphere, okay, a positively charged sphere situated at the core of the atom, okay, a positively charged sphere situated at the core of the atom, and it is a very small in size, and the total mass of the atom is concentrated in this positive sphere, okay. Total mass of the atom is concentrated in this positive sphere, and this is known as the nucleus, okay. What is nucleus, Nana? It is, the nucleus is a positively charged sphere situated at the core of the atom, okay. You see, nucleus, what is nucleus? It is a positively charged sphere. It is a positively charged sphere and situated at the core of the atom, and the total mass of the atom is concentrated in this positive, the total mass is concentrated only in this positive sphere. This is called what, Nana? Nucleus. This is called what, Nana? Nucleus, okay. So now coming to what is proton, what is proton and what is neutron, okay. The total number of nucleons present in the nucleus is denoted by the mass number, okay, Nana. See, in general the nucleus consists of protons and neutrons. The nucleus is completely filled with protons and neutrons. The proton is denoted by P and neutron is denoted by N, okay. So the nucleus is consisting of the combination of protons and neutrons. The combination of protons and neutrons, okay. So the nucleus is a combination of protons and neutrons. The combination of protons and neutrons is also called as nucleons, okay. This is called nucleons. Nucleons means what, Nana? Protons plus neutrons. Protons plus neutrons called nucleons. The total number of nucleons present in the nucleus is called mass number, mass, okay. The total mass number, the total mass of the nucleus can be considered by the addition of protons and neutrons, okay. Now the total number of only protons present in the nucleus is known as atomic number. Only protons, okay. The total number of protons, total number of protons, okay, present in the nucleus, present in the nucleus is known as what we called, it is atomic number, atomic number, and the atomic number is denoted by Z, the atomic number Z. So the total number of protons present in the nucleus is known as atomic number, and the protons, the total number of protons and neutrons is denoted by the mass number. Mass number is denoted by A, okay. Mass number means A and the protons is Z, denoted by Z. Now coming to the total number of neutrons, okay. After completion of protons, next what is called? Total number of neutrons. Total number of neutrons present in the nucleus, okay. So the total number of neutrons present in the nucleus is known as neutron number and it is denoted by A, okay. So the total number of protons and neutrons is called mass number. So can I write like this? The mass number A is equals to total number of neutrons and total number of protons. So this is A is equals to N plus Z, and here the proton number A Z is equals to A minus N. Can I write like this? Yes, okay. Very, very important equation. Okay, Nana. See, if you want the total number of neutrons, so then what you have to do, total number of neutrons n is equals to a minus z, no? Okay, this is what the total number of protons, this is what total number of neutrons, and this is what total mass number. Okay, are you clear about the nucleus? The sum of the protons, sum of the protons and neutrons called, sum of the protons and neutrons called nucleus. Nucleus means the sum of the protons and sum of the neutrons. So, now can you tell me what is the charge of the proton? Okay, so here you have to remember all these values clearly. So, first of all I am writing the charge of the proton. Charge of the proton can given by, that is 1.6 into 10 to the power of, charge of the proton 1.6 into 10 to the power of minus 19 coulombs, which is same to electron. So, electron and proton both the charges are same. Okay, charge of the electron, what is the charge of the electron? Same, 1.6 into 10 to the power of minus 19 coulombs, but electron charge is negative and proton charge is positive. Okay, electron is a negative charge and proton has a positive charge. Sign convention is different, but the values are same. What are the units for charge? Charge units are coulombs, that is why I am writing here C. Now, what is the mass of the proton? Mass of the proton is denoted by MP. Okay, what is the mass of the proton? That is 1.67 into 10 to the power of minus 27 kg. Okay, mass of the proton. Now, coming to the mass of the electron, that is 9.1 into 10 to the power of minus 9.1 into 10 to the power of minus 31 kg. 9.1 into 10 to the power of minus 31 kg. This is the mass of the proton MP and mass of the electron Me. Now, for example, if you take a carbon atom, carbon is a atom which is having the atomic number 6, right? Carbon atomic number is what, Nana? 6. So, now here the protons, what is the proton number? The proton number is in general denoted by what, Nana? Proton number is Z. Okay. So, the proton number is in this atom, the proton number Z is equals to 6. So, what is the neutron number? Neutron number is what, Nana? A minus Z. The total nucleus consisting of 12. Okay, total nucleus consisting of 12, that is why I am writing neutron number n is equals to A minus Z. Here A is equals to 12, no? See here, A is equals to here A is equals to 12 and Z is equals to 6. What is n value is A minus Z. A means what? 12 minus Z means 6. Okay, the neutron number is what, Anna? 6. Okay, like this you have to calculate the proton number and neutron number. Okay, so this is what one example of the carbon atom. Okay, Nana. So, now next I would like to explain some of the properties of the nucleus. Okay, nuclear properties. So, in that nuclear properties, so first one is nuclear mass. Okay, so first one is what, Nana? Nuclear mass. So, nuclear mass means what? Already I have told you. Mass means it is, nucleus means it is a sum of the protons and neutrons. Now, the mass of the nucleus is what, Nana? Sum of the masses of the protons and neutrons. Sum of the masses of the protons and neutrons. Okay. In general, the mass can be usually expressed in terms of atomic mass units. Okay, atomic mass units. So, 1 AMU means what here? 1 atomic mass unit. You have to remember the formula. 1 atomic mass unit is equals to 1.66 into 10 to the power of minus 27 kg. Okay, this is a standard value. 1.66 into 10 to the power of minus 27 kg. Okay, 1 atomic mass unit is equals to. Now, the nuclear mass. Okay, the nuclear mass can be expressed as, see here, it is ZMP plus N into mass of the neutron. Here see, Z means what? Proton, number of protons. Z means number of protons into multiplied by the mass of the proton plus N means what? Number of neutrons is multiplied by the mass of the neutron. Okay, this is what about the nuclear mass. Nuclear mass means already I have given a definition. The nuclear mass means what, Nana? Sum of the masses of the protons plus neutrons. Sum of the masses of the protons and sum of the masses of the neutrons. So, mass of the proton means what? Sum of the mass of the proton means what? It is the proton number multiplied by the mass of the proton plus neutron number multiplied by the mass of the neutron. Okay. See here, are you observing ZMP and N into Mn. Here Z is what nana, atomic number, and MP means what nana, mass of the each proton, and N is a neutron number, and Mn is a mass of the each neutron. Mass of the each neutron multiplied by the neutron number, and mass of the each proton multiplied by the atomic number. This is what we called nuclear mass. Okay, nuclear mass. In general, we can write, experimentally observed that the real mass of the nuclear can be, see here, the mass of the nuclear can be ZMP plus N into Mn. Already we are having the value N is equals to A minus Z, right? N is equals to A minus Z. We can also write it as the nuclear mass ZMP, nuclear mass ZMP plus A minus Z of Mn, A minus Z of Mn. This is what completely the nuclear mass, ZMP plus A minus Z of Mn. This is what about the nuclear mass. Okay. Now here, okay Nana, remember the nuclear mass formula. Now next, coming to the nuclear charge. Okay, how can we define the nuclear charge? Okay, in general you are having the charge of the proton, right? The general charge of the proton is what? The same like electron, that is 1.6 into 10 to the power of minus 19, but proton is having positive charge, that is why it is plus 1.6 into 10 to the power of minus 19 coulombs. Now the charge of the nucleus is equal to charge of the proton. So here nucleus means it is a combination of proton and neutron. Okay, already you are having the proton charge. Now coming to, you have to know about the neutron charge. What is neutron? Neutron means it is having the neutral charge, means zero charge. Neutron does not having any charge, so that is why there is no charge for the neutron. We are only having the charge that is called proton charge. So that is why the nuclear charge is completely is a charge of the proton. Nuclear charge is equals to the charge of the proton. See here, nuclear charge is completely charge of the proton. Charge of the proton is equivalent to the charge of the nucleus. Okay, did you get ma? Because the neutron is having zero charge, so that is why nucleus is having the charge that is completely proton charge. Okay. So now coming to the nuclear radius. Nuclear radius. What is the radius of the nucleus? As of now we have discussed about nuclear mass. Okay, nuclear mass, and next nuclear charge. Now coming to nuclear radius. What is the radius of the nucleus? Okay. See here, the radius of the nucleus is in the order of 10 to the power of minus 15. Nana, please change this value. It is not 10 to the power of minus 14. It is 10 to the power of minus 15. 1, 5. Okay. The radius of the nucleus is in the order of 10 to the power of minus 15. 10 to the power of minus 15 meters. Or it can also write as femtometer. Femtometer. Or it can also write as FM, small f, small m, FM, femtometer. Okay. So can you please change this? The radius of the nucleus is in the order of 10 to the power of minus 15 meters, and the radius of the atom, here nucleus is in the order of 10 to the power of minus 15 and the atom is in the order of 10 to the power of minus 10 meters. Okay. So this is what the order given by the scientist. Okay, that is a standard order. You have to remember like that only. And next, coming to the radius of the nucleus. The radius of the nucleus is completely depend on the mass number. Mass number means what? We have denoted the mass number by A. Okay. So the radius of the nucleus is directly proportional to the mass to the power of 1 by 3. Okay. R is directly proportional to A to the power of 1 by 3. If you remove the proportionality constant, you can get the radius, that is R naught is a constant, that is R is equals to R naught into A to the power of 1 by 3. Okay. Here R naught is a constant value, and the constant value is 1.4 into 10 to the power of minus 15 meters. Here it is what, Nana? 1.4 into 10 to the power of minus 15 meters. okay, 1.4 into 10 to the power of minus 15 meters, that is R naught value. You have to remember always the equation, that is R is equals to R naught into A to the power of 1 by 3. This is what about the nuclear radius, okay, nuclear radius. Now coming to the nuclear density. Nuclear density means what? In general, density means what? Mass per volume, right? In general, the definition of the density. Definition of density means what? Mass per volume. Here it is, see, the density is denoted by mass per volume. Here volume means what? The nucleus is in the shape of sphere. Sphere volume is what? 4 by 3 into pi r cube, and in the numerator it is mass. Mass of the nucleus is what? A. Okay, mass of the nucleus is what? A. A means what? Mass of the nucleus is multiplied by the mass of the proton, that is A into 1.66 into 10 to the power of minus 27. Okay, see Nana, so mass is denoted by rho. Rho is equals to mass by volume. Okay, I am deriving the equation. Mass means what? Mass of the nucleus is A, and A means what? The mass of the nucleus is denoted by 1 atomic mass unit. 1 atomic mass unit value is 1.66 into 10 to the power of minus 27 kg, right? By volume. Volume means what? In general, the nucleus is spherical in shape. Nucleus is in what? Spherical in shape. That is why the volume of the nucleus is 4 by 3 pi r cube. 4 by 3 pi r cube. But already we know that the nuclear radius, what is the radius of the nucleus? R is equals to R naught into A to the power of 1 by 3. Okay, substitute R is equals to R naught into A to the power of 1 by 3 in this equation, that is A into 1.66 into 10 to the power of minus 27 divided by 4 by 3 into pi means what? 3.14 into R naught A power 1 by 3 whole cube. Whole cube means what? R naught cube, A to the power of 1 by 3, 3 gets cancelled. Now coming to A into 1.66 into 10 to the power of minus 27 divided by 4 by 3 into 3.14 into R naught cube into A, right? In the numerator A and the denominator A cancel. So after solving the entire equation, already what is the value of R naught? Already I told you, R naught is equals to 1.4 into 10 to the power of minus 15 meters. 1.4 into 10 to the power of minus 15 meters. If you substitute R naught value in this, you will get the density rho is equals to 1.14 into 10 to the power of 17 kg per meter cube, because it is mass per volume. Mass means kilograms, volume means meter cube. Okay, so this is what the density of the nucleus. So by this equation we can conclude that this equation is 10 to the power of 17, means after 1 we have to put 17 zeros. So that is why how larger the density of the nucleus is, right? We can conclude that the density of the nucleus is very large. Okay, and the density of the nucleus is independent of the mass number. Is this density is any dependent on mass? No, density is independent of what, Nana? Independent of mass. Density is independent of mass number. Okay, so as of now we have discussed about the nuclear mass, next nuclear charge, next nuclear size, next nuclear radius, size or radius both are same. Okay, size or radius. Next nuclear density. Okay, as of now we have discussed about these 4 properties of the nucleus. Now in the next class we are going to discuss about the nuclear quantum states and nuclear spin, next magnetic dipole moment, okay, next electric quadrupole moment. So these are the few properties. By completion of these 4 properties we are going to complete the complete nuclear properties. Okay, Nana? Thank you.